Today we're going to start our first day of graphing rational functions. And we're going to spend a couple days doing this. We're going to start off with our rational parent function. So we already know how to find our domain, vertical asymptote, and horizontal asymptote looking at our equation. So our domain is just the denominator cannot be equal to 0. So in this case our denominator is x, so we just know that x cannot equal 0. And we know that our domain is related to our vertical asymptote, so we can right away know that our vertical asymptote is x equals 0. So with our vertical asymptote, we can already draw the asymptote on our graph. So we know that we want a vertical line at x equals 0. So I'm going to draw a dotted line. And mine's in pink. To find our horizontal asymptote, we're going to do what we did yesterday. So can we divide this, or is it already in proper form? So it's already in proper form, right? We can't do 1 divided by x. It's impossible. And therefore, it's just written as 1 over x. And so the fraction part of it goes to 0. Which means our horizontal asymptote is y equals 0. So y equals 0, and I'm going to draw this one in green. So again, I'm going to draw a dotted line now horizontally at y equals 0. So there are my asymptotes. My range is like my domain. Right? So if it's an asymptote, it means that it gets close to it, but it never touches it. So my horizontal asymptote is not a part of my range. So y does not equal 0. The 2 points that you need to know for this parent function is that when you plug in -1, 1 divided by -1 is just -1. So my first point I'm going to plot is -1, -1. When you plug in 1 divided by 1 is just 1. So my second point is going to be 1, 1. With these 2 points, I can now draw the rest of my graph because it just approaches the asymptotes without ever crossing them or touching them. Right, so for both of these, now I'm just going closer and closer to each of the asymptotes without ever touching them. So this is my parent function. Some characteristics. So this is reflected across there's symmetry across the origin, so therefore it's odd. It's also 1-to-1 because it passes the vertical and horizontal line test. There are no intercepts because it doesn't cross the x or the y axis, but it is decreasing from, so we always go left to right, -infinity to 0. And this section is actually also decreasing, 0 to infinity. Because if you go left to right, this one's also going down. So nowhere is it increasing. Now to draw the rest of our rational functions, these are the steps we're going to take. So first step is to factor it. Then we're going to find the domain and all the asymptotes and sketch them like we just did for this one. And then we're going to find and plot all the intercepts. So for our x-intercepts, we're going to go down here. X-intercepts are actually when your y is equal to 0. So what we would do is plug in 0 for my f of x. And we've done problems like this before. When you try to get rid of a fraction, we want to multiply by the denominator. And that just leaves you with the numerator. And what's 0 times anything? It's still 0. So whenever you're looking for the x-intercepts, we're really just looking at the numerator. So you only want to find the roots or the zeros of your numerator when you're trying to find the x-intercept. And then we're going to use sign analysis, which is just looking at is it positive or negative, to figure out where our lines should go, and connect them all using smooth curves towards each of our asymptotes. Let's take a look at example number 1. So first step, factor. Let's look at our first problem. The numerator, can you factor something out of this? Yep, we're going to take out 2. Leaves you with 2x minus 2. Can't take anything out of the denominator, so we just leave it as it is. Okay, so let's start off with our domain. We already know how to find this. Denominator cannot be equal to 0. So add 1 to both sides. Our domain is x cannot equal positive 1. So therefore, our vertical asymptote is x equals 1. So I'm going to start off right now by drawing that. So let me label my graph. This is 1. So I want to draw a vertical asymptote at x is equal to 1. So it's going to go up and down at x equals 1. So I'm going to draw a dotted line right here at x equals 1. For my horizontal asymptote now, I'm going to be using long division like we did yesterday. So we have 2x minus 4 divided by x minus 1. We're going to use this original function at the factored out one. When you do 2x divided by x, it gives you 2. So we put 2 up here. 2 times x, 2x, 2 times -1, -2. change the signs, you get a remainder of -2. But remember, the remainder doesn't matter, right? Because if you were to rewrite this, it would just be 2 plus -2 over my original function, my original denominator. This goes to 0. So you're really just left with this. This is the only thing you care about, is the answer. And if it's a number, then this is your horizontal asymptote. So my horizontal asymptote is y equals 2. So again, I'm going to draw this on my graph. Y equals 2. I'm going to draw a dotted line right there. So now I've drawn my asymptotes, and I'm going to go on to my intercept. So for my x-intercept, this is when y is equal to 0. So just like we talked about down here, when y is equal to 0, we're going to plug in 0 for f of x, but we only care about the numerator. So 2, I'm going to use the factor version, x minus 2. If we're solving for 0, we can just divide by 2 to get rid of that, this 2. And it leaves you with 0 equals x minus 2. Add 2 to both sides. We get x is equal to 2. And we want to write this as a point. So my x value is 2, my y value is 0, so this is 2 comma 0. And now I can plot this on my graph. So right here, 2 comma 0 is right here. So this is my first intercept. For my y-intercept, this is just x is equal to 0. So all I need to do here is plug in 0 every time I see x. So I have 2 times 0 minus 4, 0 minus 1. So again, this is just for my original function. Every time I see an x, I want to plug in 0. Simplify, 2 times 0 is 0, minus 4 is a -4, 0 minus 1 is a -1. So -4 divided by -1 is just positive 4. And then again, write this as a point. So 0 is x, so 4 is my y. And again, I'm going to plot it, so I'm going to go up to 4, which is up here, and draw a point. That is my y-intercept. So now that I've done all that, all I have to do now is draw my graph. So to do that, I'm going to do something called sign analysis. So we know that our function can only change signs at our x-intercept or vertical asymptotes. So what we're going to do is plot all of our x-intercepts and vertical asymptotes on a number line. So our vertical asymptote is at x equals 1. So I'm going to label 1 and draw a dotted line, because that's my vertical asymptote. And then I have an x-intercept at 2, so I'm going to draw a dot right there. So I have all my x-intercepts and vertical asymptotes. What I want to figure out is if it's positive or negative in each of these sections. So I'm going to start off to the left of 1. So I'm going to pick any number to the left of 1. So let's say 0. What I want to do is plug in 0 into my function and see if I get a positive or negative number. So if I plug in 0, we are actually already plugged in 0 right here for this y-intercept, but I'm going to do it again. So 2 times, this time I'm going to plug it into the factored form, because this is going to be easier for me to see. I don't actually care what the number is. All I care about is whether it's positive or negative. So in this top portion, 0 minus 2 is going to give me a negative number, right? So negative number times 2 is going to be negative. 0 minus 1 is also going to give me a negative number. So I'm going to end up with a negative divided by a negative. What's a negative divided by a negative? It's positive, right? So again, I don't even have to write the numbers down. All I care about is the sign. So I know this is going to be a positive number on this side of the 1. Now right here, between 1 and 2, I'm going to plug in a number that's somewhere in between 1 and 2. So a number between 1 and 2 is, let's say, 1.5. So again, I'm now going to plug in 1.5 into my factored part and see, is this going to be positive or negative? So 1.5 minus 2, is this going to be positive or negative? So 1.5 is smaller than 2, so if I'm trying to take 2 away from 1.5, I'm going to end up with a negative number. 1.5 minus 1 is going to give me a positive number. And what's negative divided by positive? It's negative. Right, so in between the 1 and the 2, I'm going to have a negative numbers. Last thing I'm going to do is plug in a number on this side of the 2. So some number bigger than 2, let's say 3. So we plug in 3 in for all my x's. 3 minus 2 is going to be 1, so I know it's going to be positive. Right? 3 minus 1 is going to be also positive, because it's going to be positive 2. Positive divided by positive is just positive, so on this side it's going to be positive. Okay, Okay, so this is my sign analysis. This is going to help me draw my picture because now I know where my lines should be. Should they be above or below the x-axis? So let's go to our graph now. So I know, here's my intercept at 1. Everything on the left side of 1 should be positive, which means above the x-axis. So everything on the left side should be above the x-axis. So I already have this point right here, so let me start with this point. I know that this should stay above the x-axis, so I'm just going to draw a line from here to this asymptote. And this one is also going to, it's not going to go down because I know it can't cross the x-axis, it's got to stay above, so this is going to go up towards this asymptote. Okay, so this is this part of my graph. Between 1 and the 2 I want it to be negative, so I want it to be below the x-axis. So here's 1, here's 2. So I know that from here I want this part to be below. So I'm going to draw this going down towards this asymptote. Because otherwise it might be going up towards this one, but I know it's negative, so it should be going below the x-axis. On this side of 2 I want it to now be above the x-axis. So again, this one's going to be going up, and there's an asymptote here, so I want it to get closer and closer to this asymptote. So this is my final drawing for number 1. This is my rational function graphed. Ta-da! Okay, let's do a couple of other examples. So for number 2, step 1, factor. Is there anything you need to factor? No, we're good to go. Let's start off with our domain. So the bottom part cannot equal 0. So x minus 2 squared is the same thing as x minus 2x minus 2. So really we just need one of them because they're going to give us the same answer. All right. And when you add 2 to both sides, we know our domain is x cannot be positive 2, which means our vertical asymptote is x equals 2. So I can already start off by drawing my vertical asymptote at 2. My horizontal asymptote now I'm going to find by dividing, so using long division. When I try to divide 3 by x minus 2 squared, can I do that? No, it's already in proper form. So if it's in proper form, what does this fraction go to? It goes to 0. So I have a horizontal asymptote at y equals 0, which is just going to be a line on the x-axis. So at 0, it's going to be on the axis. Okay, so for my x-intercept, again, I'm going to set the numerator equal to 0, because this is when y is equal to 0. So I'm going to say numerator equals 0, so 0 equals 3. Is this a problem I can solve? Is there ever going to be a situation where 0 equals 3? No. So therefore, there are no x-intercepts at all, because there's never an x value where 0 equals 3. That's impossible. For my y-intercepts, x is equal to 0, so this just means I'm going to plug in 0 every time I see x. And that gives me 3 over negative 2 squared. Negative 2 times negative 2 is 4. So I have x value is 0, my y value is 3/4. And this is going to be a point I'm going to plot. So let me draw my y's. So if my y-intercept is at 0 3/4, 3/4 is a fraction slightly less than 1, so I'm going to just draw a point right here that's a little bit less than 1 between the 0 and the 1. Okay, great. Let's do our sign analysis. So again, I'm only caring about the vertical asymptote because I'm just plotting my x's. So x equals 2, and is there any x-intercepts? No. So the only thing I'm looking at here is the 2. So left side of 2, right side of 2. Okay, so again, we're going to pick a point on the left side of 2. So let's use 0 because we already did 0. So f of 0, did that give me a positive or negative number? It's positive, right? Because 3/4 is positive, so this side's going to be positive. Now let's pick another number on this side, so let's say 3, because 3 is bigger than 2. So f of 3 is, let's plug it in, 3 over 3 minus 2 squared. So 3 is clearly positive, right? 3 minus 2 is 1. 1 squared is also going to be positive, so this is also going to be positive. So for this case, both of these sides are going to be above the x-axis. So they're positive, so above the x-axis. So let's go back to our drawing. So 2 is my vertical asymptote, which is this pink line right here. So on the left side, I want it to be above the x-axis. So over here, this is the point I'm going to connect it to. So it's going to stay above the x-axis, and this one is also going to be going up above the x-axis. And for this is a section that's really important because I don't know where my graph is because there's no point here at all. But because I know it's above the x-axis, I know it's going to be going up here towards this direction because I need it to be above the x-axis. If this was negative, then it would be down here instead of over here. Either way, it's got to go towards the asymptotes. So this is my graph for number 2. We're going to do one more example. So number 3, step 1, factor. So top one we can't factor at all, but this one we can factor, right? 1 multiplies to give us -2, adds to give us -1. So we know it's going to be 2 and 1. Which one of them is going to be negative? The 2. So because there's no number in front of x squared, we don't need to do the box. We can just go straight into x minus 2, x plus 1. Okay. Once we have it in factored form, it's going to be easier for us to find the rest of these. So domain, denominator cannot be equal to 0. So we already factored this out, which is great. So when you factor it out, we're going to separate them. So x minus 2 can't equal 0, x plus 1 can't equal 0, and we end up with x cannot be positive 2 and negative 1. So our vertical asymptotes, this time we actually have 2. We have one at x is equal to 2 and x is equal to negative 1. So when I draw my vertical asymptotes, I'm going to have 2 of them. One at positive 2 and one at negative 1. So I have 2 vertical asymptotes in this situation. Horizontal asymptote. So now I'm going to try to divide x divided by x squared minus x minus 2. Can you do x divided by x squared? No, it's already in proper form. So if this is the proper form, what happens to this fraction? It goes to 0. And so y equals 0 is my horizontal asymptote. So again, I'm going to draw this. Y equals 0 is just on the axis. And those are my asymptotes. Okay, x-intercept, so I want my y to be equal to 0. So 0 equals the numerator. The numerator is just x. So this is actually really simple because x is equal to 0. So 0 and y is also 0, 0. 0, 0 is my x-intercept. I'm going to plot a point right here. For my y-intercept, if x is equal to 0 and I plug it in, so 0 divided by 0 squared minus 0 minus 2. This gives me 0 over negative 2, which is also 0. Which makes sense. My x-intercept is 0, 0, my y-intercept is also 0, 0. So that's the only point I know. Okay. So this one, now let's do our sign analysis. So again, we want our vertical asymptote, so our x's. So we have a 2 and a negative 1. Negative 1 is on the left side of 2. We also want to plot our x-intercept, so 0. So these are my asymptotes, this is my x-intercept, and I want to know what's happening in between each of these. So let's start off to the left side of negative 1. So let's say we pick negative 2. If we plug it into our function, so we're going to use our factored form now. X is negative 2. Negative 2 minus 2, negative 2 plus 1. Again, we only care about whether it's positive or negative. So negative 2 on top is negative. Negative 2 minus 2, it's getting even more negative, so this is still negative. Negative 2 plus 1 is actually going to be negative as well. So what's negative times a negative? It's going to be positive. But what's negative divided by a positive? This is going to be negative. Right, so this section is going to be negative. Because when you multiply negative times a negative, it's going to give you a positive. But then you have a negative divided by a positive, gives you a negative. Okay, so let's pick this section right here now. Somewhere in between 0 and negative 1. So let's say we pick negative 0.5. Negative 1/2. So if I plug in negative 1/2, it's going to be negative 0.5. Negative 0.5 minus 2. Negative 0.5 plus 1. So the numerator is still going to be negative. Down here, negative 0.5 minus 2 is going to be negative. Negative 0.5 plus 1 is going to be positive, right? Because this is a smaller number than the 1. So a negative times a positive is negative. This is still negative. What's negative divided by negative? Positive. So this section right here is positive. So between 0 and 2, let's pick another point here. Let's say 1. So with 1, if we plug in 1, it's going to be 1 divided by 1 minus 2, 1 plus 1. So this is clearly positive on top because 1 is positive. 1 minus 2 is going to be negative. 1 plus 1 is going to be positive. So negative times the positive is negative. Positive divided by a negative is negative. So this whole thing is going to be negative. Finally, we're going to pick one more number for this last section. Let's say 3. So 3 over 3 minus 2, 3 plus 1. So positive, 3 minus 2 is positive, 3 plus 1 is positive. Positive times a positive is positive. Positive divided by positive, still positive. So this is my sign chart. So now we can use this to draw our graph. So here's negative 1. Right. On the left side of negative 1, I want everything to be below the x-axis because it's negative. So that means I just want this section to be down here, where it's still approaching both asymptotes, but it's just underneath the x-axis. Between negative 1 and 0, I want it to be above the x-axis. So this should be going up towards this asymptote, because it should always be approaching an asymptote. Between 0 and 2, I want it to be below the x-axis, so this one should be going down towards this asymptote, since it's below. And finally, on the right side of 2, so on the right side of this asymptote, this should be above, so this section is going to be above the x-axis, approaching both asymptotes. This is my final graph for number 3.